Hello, here we have the exercise 37, page 110. This is about projectile motion. We start with the exercise and we solve the first part in where we have a first question, and the first question is how close horizontally to enemy ship does the projectile land? Okay, I solved the exercise, and how you can see we have a procedure step by step until we have a horizontal displacement. Okay, here we found, first of all, with the formula of horizontal displacement, but we don't have a time. And then remember that in class, as a conclusion, we have, because we have a projectile, okay, and this projectile land in this position, okay. So we need to know what is the distance basically with the enemy ship, okay. So solving the exercise, here we did it in class. So this horizontal displacement is equals to 3,188.76. Here we have step by step. And remember that vertical displacement, this is equal to 0, because after the motion that we have, okay, so at the end, we don't have a vertical displacement because this is the same line of reference, okay? So if we have that this is 0, solving by this equation in where we have a vertical displacement equals 0, a common factor, everything that we saw during the class. So here we have the answer that is 3,188.76 meters as a horizontal displacement. But the question is, okay, does the how close horizontally to the enemy ship does the projectile land? Okay, so what do we have to do? This horizontal displacement, the projectile land, okay, is that simple. It's just this horizontal displacement, and we need to subtract the addition of all the horizontal that we have here, okay? So the answer for this is 78.76. The second part of the exercise is how close vertically the projectile come to the peak. Okay, great. Here we have the peak, and remember that we should have a vertical displacement greater than 1.80 times 10 elevated to the third power, okay? So knowing that, here we have the sequence, and the sequence that we have is the same, okay? We don't know the time, because remember that this is another time, and this is the reason why here we have interval of time prime and initial displacement, horizontal, okay? Just move to the other side, initial velocity with the cosine of the angle, and here we have the time. But in this case, I need to know this vertical displacement, okay? It's not 0. It's not 0. So there we have the equation, okay? So instead of the time, we will substitute by this equivalent expression, okay? That is horizontal displacement initial over initial velocity cosine of the angle. Instead of this time, I'll substitute with this, and here we have. Again, here we have to the second power, so here we have to the second power. Okay, and now I just need to apply the multiplication. Something important here is the look. You have initial velocity as a numerator and initial velocity as a denominator. You're allowed to cancel this, okay? And then sine over cosine, this is a tangent, okay? This is an identity trigonometry. Sine over cosine is a tangent. It doesn't matter if you don't simplify this. My answer will be exactly the same. And now here is a multiplication, but we have this initial horizontal displacement elevated to the second power, initial velocity to the second power, and cosine of the angle to the second power as well, okay? So this is what we have now, okay? Horizontal initial displacement, sine over cosine is a tangent. And now in the other part, I told you that you have horizontal initial displacement to the second power, initial velocity to the second power, and cosine to the second power. So with your calculator, you need to substitute. Okay, you need to substitute there. Remember that this is initial, okay, and this is the vertical. Knowing that, okay, something important here, how you can see in the exercise, acceleration in y or the vertical acceleration is negative. Okay, so here this is the reason why here we have the negative. Okay, because this vertical acceleration is negative. If you substitute in the calculator, the multiplication of this is equals this, and this is equals this. So because of the negative acceleration in y, we have a subtraction. So this vertical displacement is equals to 2007.85. Okay, 2007.85 is greater than 1.80 times 3 times 10 elevated to the third power. Okay, so now we need to subtract 2007.85 minus 1.80 times 10 elevated to the third power, and this is the answer. Okay, so this is the distance about the peak. So basically here, those 207.85 meters representing a distance from this point over, okay, the peak that we have here. And this is the exercise 3, page 110. In Edubox, you will have an assignment, a couple exercises that you need to copy and solve, convert in PDF, and then upload it in Edubox. Something important, you need to convert all the files as a PDF. Okay? Have a great day, and I'll see you in class.